Hi, today we're going to be solving this circuit diagram. We're going to be solving for each of the currents in each of the branches of this circuit diagram. And you'll notice that there are 6 currents, so that gives us 6 unknowns, so hopefully we'll be able to come up with 6 equations from this circuit diagram. So one of the first things that we might want to notice is the direction of the E field along components in this circuit. So right off the bat, what I'd notice is that along this first battery right here, the E field points from right to left. The reason for this is because a positive chest charge would move from the positive end of this terminal to the negative end of this terminal. And we could do something similar here along this resistor here, this very first resistor. What we notice is that a positive test charge that's kind of being spat out of the positive terminal of this battery is going to go all the way around this loop. And so the E field then, for this component, actually points this way, like this, to the right. So what we can say then, because we're going to want to sum up all of the voltages along this entire loop as kind of our first set of equations, we want to find the voltage along each of these. And so the sign of these voltages becomes very, very important. Okay, so what we may recall is that the delta V, the change in the difference in voltage from one side to the other of any component in the system is going to be negative E dot D. And so what we might say here is that, you know, and this D could be a length, for example, we could write this E dot L, for example, negative E dot L. But the key here is this negative sign. And so what you'll notice is that if, for example, we start our loop right here at, say, point A, then what we're going to do is we're going to have because we're moving against this E field, we have a negative sign with another negative sign coming from the dot product of these two directions. So we're actually going to get a positive voltage along this battery. Then we're going to go with the E field here, so we're going to have a negative sign for this battery. Now, one way that I like to think about this is that if we're going across a resistor, and we're going in the same direction, notice I1 is to the right here, as is the resistor, the E field across the resistor, then we should have a negative sign in front of that component for voltage. Okay, so all of that being taken into consideration, what I'd like to do is start writing out the voltages for each of the sum of the voltages for each of these loops. So this is what we call Kirchhoff's loop rule. Kirchhoff was a physicist who figured this stuff out. So his loop rule tells us that we're going to sum up all of the voltages in any particular loop, and that sum should give us 0. So here, let's take this loop 1, for example. So loop 1, we're going to start at point A. Doesn't matter where you start and end, I'm just picking a spot so that we can kind of work through this together. So I'm going to always start off with these Kirchhoff loop problems with a 0 equals, because I do, again, know that it's always going to start off that way. So here I am. If I start at point A, then I'm going to have a positive battery voltage, so that'll give me 20 volts. I'm going to leave off the units here for simplicity. Then I'm moving against this resistor, so this is going to be a minus 10 I1. Notice I1 is the current moving through resistor, with this resistor with 10 ohms, and so the voltage for that resistor component is I times R. So here it is, I1 times that 10 ohms, R. Okay, so now we keep chugging along here. Now again, here I'm dealing with an I4 along this branch. Okay, so I have this I4. We're moving in the direction of I4, so it should be another negative sign as we move across that resistor. So this is going to be minus a 15 I4. Then I'm going to move up this branch. Notice again that I'm moving with I6, so this is going to be a negative 12 I6. Then I'm going to come down all the way around. Now notice that this is the same branch as I1 was traveling in, so we still have I1 going in the same direction as we're moving. It should be going up this branch. So we're going to have a negative 20 I1. That gives us our first equation. So here I'm going to label this equation 1. If I had had room off to the right here, I probably would have written it there. Okay, so that gives us our first equation. Now I'm going to do loop 2. In this case, I'll start at D. at point D here. So here's D. D is at the top. So the first thing I'm going to do is I'm moving clockwise around this part of the circuit. So I'm going to move down this along this branch, which means that I'm actually moving up in voltage. I'm moving up this battery, moving from the negative terminal to the positive terminal. So again, my equation always starts 0 equals, and because I'm going from negative to positive on that battery, I'm going to have a 5 volts there, and in fact I already mentioned that I wasn't going to use units, so I'm going to leave that off. Okay, now this is where things get interesting. I'm going to move up and to the left along this part of this branch right here. Notice that I'm moving against the current. Now that I'm moving against this current I4 here, this becomes a positive IR. So in this case, positive 15 I4. And then I'm going to continue this to make my way back to D to complete this loop 2. So now I'm moving in the direction of I2, so I'm going to have a negative 20 I2 here. This gives me my second equation, equation 2. The reason that I'm labeling this is because I'll be using these equations in the next part of this video, which I will link to at the end of this video, to actually solve this entire system of equations. Okay, now let's keep going. We'll continue on with loop 3, where we'll start at point E on this circuit diagram. So point E is down here at the bottom. It does not matter, again, where you start or end. I'm just doing this for consistency. So here we're starting here at the bottom. Notice that loop 3 is also moving clockwise in this part of the circuit. Now notice what's happening is the first thing I'm going to do is I'm going to move against the battery. I'm going to go from the positive end of this terminal to the negative end of this terminal. So I'm essentially losing that voltage. So I have a negative 5 volts there to start off with. Now I'm moving in the same direction as I3. That gives me a negative 30 I3. And I continue this process on the last branch. Here I'm moving against the current. Again, this is an interesting case. So that gives me a positive 12 times I6. This gives me my equation 3. So there it is. Those are the 3 loops of this circuit. Those are all of the loop rules that we can write down. Now we're going to focus in on the node rules. So node rules tell us that however much current goes into a node must be the same as the total current coming out of a node. So in other words, the sum of all of the current in equals the sum of all of the current out. Okay, so I'm going to pick 3 different nodes somewhat arbitrarily. So I'm going to choose node C. That will be my first node. So let's start there. So we're choosing this node. So first thing that I'm going to do is pick out which currents are going into the system. I have I1 goes into this node, whereas I2 and I4 come out of that node. So all of my currents going in are just I1, and all of my currents coming out are I2 and I4. And that's it. That's my node equation. So this is, I'm going to label this as my equation 4. Okay, the next node that I'm going to look at is node D. Again, no particular reason that I've chosen these exact nodes. You could have chosen different ones and you will get the same result for your system. Since this is in reality a physical system, so we can't possibly have different solutions for this. Okay, so at node D, the only current that I have coming in is I2, and the currents that I have coming out are I3 and I5. So this is I3 and I5. This I'm going to label my equation 5. And then finally, the last node that I'm going to look at is node F. I could choose to look at node E, but since I only have 6 unknowns, I only need 6 equations to solve this. So here it is, node F. Okay, currents that I have coming in are I3 and I6. Currents that I have coming out are I1. So I3 plus I6, this equals I1. Again, I just want to make sure that we're clear here. This I1 that's moving through this resistor is the same I1 that's moving this way. It's the same I1 that's moving this way and all the way over here, right? This is all essentially the same branch of the circuit. So that's all the same current there. Okay, great. So now I have 6 equations, 6 unknowns. Stay tuned, watch the next video. I'll put a link to it right here so that you can actually see how to solve this system of 6 equations by hand. See you then.